The Bengal is proverbially the land of rivers. It has intricate network of rivers drained by Ganga, Brahmaputra and the Meghna in East Bengal, and its numerous tributaries and distributaries channels. So in Bengal we call it Nodi Matrik, or land nourished by the river. The three major components made Bengal ecologically productive. It has plenty of water carried by the Ganga Brahmaputra system. It has bright sunlight and the most fertile land built by the rivers. So in colonial text it was said as paradise of India. It was so productive that you can just throw away seeds and can produce. Ganga has a large catchment, more than 1 million square kilometer, covering about 11 states of India, starting from Rajasthan down to Bengal. And Bengal offers ultimate outlet of the water to Bay of Bengal. Brahmaputra is not exactly draining West Bengal, but its tributaries now draining North Bengal like Mahananda, Tista, Jaldhaka, Torsha, they ultimately join to, except Mahananda, 4 others goes to Brahmaputra in Bangladesh. Broadly we can divide the rivers of Bengal into the Ganga Bhagirathi system. The Bhagirathi means the rivers which flows along the Kolkata, and the rivers of the North Bengal, rivers of the Rar Bengal draining the western districts of Bengal, and the tidal creeks. If you look at the western side, this river, there are 7 rivers draining from Chotnagpur plateau, coming eastward, ultimately discharging into the Bhagirathi Hooghly river, the Damodar being the largest one. There are other Mayurakhi, Ajoy, Kasai, etc., etc. These are all east flowing rivers. And there are some distributary channels from here in Murshidabad, Jalangi and Churdi. The Ganga bifurcates Bengal into 2 unequal halves. It enters Bengal near Rajmahal Hills, flows southeastward, ultimately reaches at Farakka Point, and then it flows along the Indo-Bangladesh border for about 102 kilometers, ultimately enters the Bangladesh. There are some intricate network of tidal creeks having no connection with the upstream stream. They are tidally induced creeks. Extreme spatial and temporal inequality of rainfall creates 2 types of hydrological extremes in Bengal. One is flood, other is water short condition. So these are 2 kinds of hydrological extremes we experience not only in Bengal but in the entire country. Water short condition seems to be a greater challenge for Government of India always, because flood affects about 10 to 12% of the total geographical land of the country, while water short condition during April, May can affect about 1/3 of the population and 1/3 or large part of the country belonging to peninsular India. Why it happens? If you look at the discharge hydrograph of any river, discharge hydrograph is a simple thing. Horizontally you keep the month, and vertical axis you keep the how much water flowing through that particular point. The water, it is a peak during July, August, September, followed by a time when water falls. Even rivers goes dry. But if you look at the cross-sectional area, how much water it really can carry from bank to bank, maybe this is the limit, here is the limit. So anything excess of this will spill off and devastate the human civilization. The British had an understanding that we can tame the we can manage the flood. Their intention was to keep the water within the bank to bank. But this volume of water is extremely difficult, or rather quite impossible to accommodate within the narrow cross-sectional area of the river. So what they did? They embanked our river system. From 19th century, they started to intervene our river system. First intervention was made at Damodar river, which was described as the sorrow of Bengal. This is the flood situation. I extracted this from in Malda. It was a century highest flood, entire Malda district, and we often think that we can accommodate the water within this narrow area. It is virtually impossible. This is 2000 September flood. Entire South Bengal, here you will find that it was submerged. This is called embankment. They built linear embankment, high embankment like this. What happened thereon? We achieved freedom from low intensity flood. But what subsequently happened, the water which carried the sediment load and spilled off and deposited the sediment load on the floodplain, fertile agricultural land, the river was compelled to deposit the sediment load here within the river bed. It interrupted the sediment dispersal mechanism, and fertility or agricultural fertility gradually fall. If you don't allow the water to spill off on the agricultural field, you are also not allowing to drain the water coming into this area. That means rain falling here could not find any way to come back to the river. Whenever we discuss the flood, we don't include the railway authority in flood management. It was decided that the railway line should be laid on embankment above the highest flood level. So, what they did, they again created linear embankment, and they created linear borrow pit to borrow the soil to create such embankment. Result was that borrow pit subsequently became the breeding ground for the malarial mosquito. After post-independence period, we started the dam building, and DVC, Damodar Valley Corporation, was the first multi-purpose river valley project of the country. It was an engineering marvel. It is extremely difficult task to make such a huge reservoirs, and we did it. But what happened subsequently? The sediment deposition in the reservoir has reduced the cross-sectional area and water holding capacity of the reservoir. So, what they do? DBC authority takes a calculated risk of keeping the reservoir full during July, August. Because according to them, say September rainfall is very uncertain. It may happen, it may not happen. We will have to ensure irrigation. They have the apparently pious intention. Result is that if you look at these DBC reservoirs, how the sedimentation has lost the capacity. So, Maithon, more than 30% it lost. Panche, it is about 22%. Tilaiya, nearly 53%, and it is Konar, which is 38.48%. I had been the member of the National Flood Management Group. We discussed that the flood management should switch over from ongoing relief-centric reactive program to preparedness-driven approach. Preparedness means you must have a very good early warning system. Nowadays, IMD has developed a unique system of satellite monitoring. They can, even the cyclone tracking is very excellent. So, we can coordinate with them, and they have a guide curve. If there is a forecasting there will be rainfall in Jharkhand, can DBC authority release a portion of the water so that they can accommodate the additional water? This is the discussion going on. Second issue is that which should be the best possible outlet of the flood water. So, that line should be opened first. And third is the preparedness-driven options means where to locate the flood victims. So, these are the proactive, and the food storage, medicine supply, etc. These are all major issues. So, this is till date it is often reactive, but it should be proactive. Here is the Rajmahal rock, very hard rock barrier. So, it shifted towards formed a mighty bend. And I was looking at the multi-dated images and try to understand how the river behaves. About 200 square kilometer land have been eroded from 3 blocks of the Malda district. And even we are afraid that during a disastrous flood, Ganga can outflank the Farakka barrage and open a new outlets towards the Bangladesh. I was also looking at what changes happens in Murshidabad, downstream of the barrage. If you look at that, in 1977, a place called Akhriganj, river was flowing like this. If you can see, there was a paleo channel bend here. River came to that place in 2002 and again went back. So it oscillates like a pendulum. Right, left, like this. Here's another place called Jalongi. If you can look at this old bend, it came here in 2002 and again went back. And if you look the disaster like this, the Ganga is so mighty, so powerful. It impinges the bank. What we did, we tried to protect with the boulders. What kind of structure we built? Like this. It is a hugely expensive task and it washes away. Let us allow the river to oscillate within it, and whatever amount we incur on the bank protection should be incurred for the rehabilitation of the people. This had been recommended to the Government of India by the 7 IIT committees, and I was initiating that move, that river needs a space. The tropical Indian Ocean sea surface temperature is ever increasing. This is at the highest rate compared to the global average. It is at the rate of 0.5 degrees centigrade per decade, while global average is 0.06 degrees centigrade. This invites formation of the cyclones in the Bay of Bengal. And second issue is the sea level in Sundarban is rising at the rate of 3.6 millimeter per year, plus land is subsiding at the rate of 2.9 millimeter. That means effective rise of the sea is 7 millimeter per year, and that leads to gradual encroachment of the. And during the cyclone, as we explained last 26th of May last year, disaster quote unquote may be a weak expression to describe what happened thereon. Intensity of cyclone is ever increasing. The climate change in Bengal, not only in Bengal, is so complex. It is not only that sea surface temperature is increasing, our rainfall pattern is also changing. If you just link it with our agriculture, our kharif cultivation is the main agriculture here. What farmers do, they create a kind of nursery bed and wait for the rain to come in. Whenever rain comes, they transplant that. But when the rainfall is delayed, what do? They rely more and more on groundwater table. Result is, believe me, the groundwater in the Bengal Delta is depleting at the rate of 20 centimeter per year. In 1780, the Sundarban of undivided Bengal was 20,000 square kilometer. Now it has been reduced to about 10,000 square kilometer, 10,400, and it is shared by West Bengal 4,262 square kilometer and Bangladesh remaining part. It includes water body too. I was just excluding the water body from West Bengal part. If you exclude the water body, it will come down to about 22,000 square kilometer, 2,200 square kilometer. That is 50% is the water body. I was also monitoring the forest part, where there has been no embankment, where the normal tidal dispersal continued, and that region had went up about 1 meter to 1.5 meter above the area where people now live. From western part, we deforested everything. Result is that decay of the river, and we allowed the cyclone to come in. The forest cover protects the interior land from the thrust of the wind. But this western part, we don't have any. This happens. You can see the beaches in the embankment, and you can also see the level of the water, which is far above the adjoining ground. And I was discussing this, the 4 cyclones. If Ayla in 2009, look at the high tide was 4.20, and Bulbul in November 2019, 4.7, and Amphan 4.67, and last one was 7.5 meter. This is the highest. The tide level is ever increasing. And if you look at the wind speed, if you look at Amphan was the very severe cyclone, and here it was 130 to 140 kilometer, and since wind speed, water level was very high, so it just took away everything. What we did, we were trying to find some vegetative solution. We said that, okay, 90% of the embankment are earthen embankment. Can we create a vegetative wall in front and beyond, so that that absorbs the first thrust of the wind? And it is so far accepted. We are exploring this to create vegetative wall in both in front and beyond, wherever the space is available. But in case of coastal region, we propose parallel dike, one here, another here, and the area in between, the 500 meters should be declared as no construction zone for creating a vegetative shield thereon. The rivers are drying. What we recommended in the IITs to the government of India, the 4 ways to save the rivers, and including Ganga. The flow must be Abirol. It must be continuous Abirol Dhara. So, these dams disconnected the river, and downstream is made dry. We should understand that at least some ecological flow should be allowed to flow into downstream. Second is, flow must be Nirmal, so we should not discharge wastewater into the river. This is also order from the National Green Tribunal. River is a geological entity. It is a part of the hydrological cycle. So, we will have to understand that this geological entity, this hydrological cycle should be allowed to operate. If you think that we shall store the entire runoff and will not allow a single drop of water to go into the Bay of Bengal, we are opposing the hydrological cycle. And last one is the ecological entity of the river. River, human society is not the exclusive custodian of the water. All other living beings have their right. At the conclusion, I would advise you to read one book. This book was written by Barry Commoner. Barry Commoner was a physicist. Subsequently, he became ecologist. He said 4 laws of ecology governs your existence. First law, we are living in an ecosystem where everything is connected to everything else. Second law is it is a dynamic system, everything must go somewhere. Third law, there is nothing called free lunch. Everything has a cost. Whatever you do, you will have to pay a cost. And fourth law is very close to my heart. He says, nature knows the best kind of engineering. Don't try to alter the nature too much. Try to live with nature, and there lies the clue of your existence. With these few words, I stop here. I believe I will leave some more days so that we can do the needful or help you as far as I understand the river science.